Hello, class. This section is on flags. A flag is a Boolean or integer variable that signals when a condition exists. Okay, a flag is typically a Boolean variable that signals when some condition exists in the program. When the flag variable is set to false, it indicates that the condition does not exist. When the flag variable is set to true, it means the condition does exist. For example, suppose the program that calculates sales commissions has a bool variable defined and initialized as shown below. So here we have bool, okay, that's the data type, sales quota met equals false, right? So with that bool data type, that means it can, sales quota met can be either true, false, yes, no, on, off, 1, 0, all right? So in the program, the sales quota variable is used as a flag to indicate whether a salesperson has met the sales quota. When we define a variable, we define the variable, we initialize it to false because we do not yet know if the salesperson has met the quota, right? So that's like in any program, you started off at 0 and then you would accumulate as the person would have made the sales. You wouldn't start them off with having sales without having them work or had started working. Okay, assume a variable named sales hold the amount of sales. Okay, code similar to the following might be used to set the value of the sales quota met variable. So here, if we look at this, we have if sales. Now, sales, remember, was what? The number of sales that the person made for that particular time period. So say we was dealing with a car dealership and a person had to meet a quota of 3, all right? So quota amount can be some constant amount that we can set, all right? Because what? The quota would be that standard, okay? This is the quota, all right? When the sales, that would be the number of sales the person would actually have. So if sales, okay, so if I'm a car dealership, if I sold X number of cars, all right, if it's greater than or equal to the quota that I have to get to, then I'm setting sales quota met to equal to true, all right? Otherwise, I'll set it to equal to false, which is already equal to false if this statement has already been set, but we'll set it to equal to false if this is not true, all right? So as a result of the code, the sales quota met variable can be used as a flag to indicate whether the sales quota has been met, all right? Later in the program, we might test the flag, you know, in the following way, using an if statement, if sales quota met. So sales quota met is going to be equal to either true or false, right, in this particular case, right? So if sales quota met, that means what? If it's anything other than what? 0. So true is 1, all right, on. False is off or 0. So here we go. If sales quota met, so if a salesperson did sell 3 or more cars, then what? Sales quota will be set to true, and then we could say if sales quota met, which means if it's true, then we're going to output you have met your sales quota, all right? And this code, it displays the you have met your sales quota if the bool variable sales quota met is true, right? Notice that we did not use the equal operator, right, to explicitly compare the sales quota met, all right? So and So what happens is it says, remember, you got to use equal equal, not just a single equal, because one equal is actually assigning it's equal to true, and it would make it true all the time. So, but they didn't use it. They didn't explicitly compare it. The sales quota variable with that with the value true, right? But it is equivalent to saying if what sales quota met is equal to true. This, what they're saying here, is similar to writing this exact same thing here, right? So you could do that, all right? So let's look at a program that I've somewhat written to see just how we can write using the Boolean values. All right. So in this program, I've created a constant integer of quota. Now, quota, in our example, we use car sales. All right. So we set our quota to 3. So if a person sells 3 or more cars, they have met their quota. All right. So we can make that a constant integer. We know our quota. Then what? Sales. Sales would be the number of sales that person have for that particular time period. Right? But then here we set our bool value to SQM to false. All right. So sales quota met starting off is false, right, which is 0. So we made I've written the program to where it actually just allowed me to input a sales quota, a number of sales. So here we got C out, and I'm doing two new lines and a tab, and saying enter number of sales, right? And then CN sales. So now, if sales is greater than or equal to quota, so quota is set to what? 3. It's constant, cannot be changed, all right? And then we input a sales. If we input 3, then we're gonna assign SQM, which is sales quota met, to true, right? If it's not greater than or equal to 3, we set an SQM to equal to false, right? Now, what happens after that is now we don't have to worry about sales, the quota and the sales. We could just take the sales quota met, right? So if sales quota met, right? If it's true, right? We don't have to know if it's greater than 3 or whatever. We just need to know if the sales quota was met. If sales quota met, all right? So if this is true, we're going to output you have met your quota for the month, right? Else, it would be false. You have not met your quota for the month. So going back here again, if it asks CN number of sales and I put in 1, then 1 would be less than quota, all right? And it would not be equal to quota. And then we would assign false. And then when it say if quota, it would be false because it's not true, it's false. So it would output you have not met your quota. All right. So let's run this program. All right. We'll run this program. All right. And now, okay, please enter number of sales. So say I put 4. All right. Hit enter. You have met your quota for the month. All right. So what happens? It asks us here if 4 is greater than 3, greater than or equal to 3. Yes, it is. So we're going to set SQM, which is sales quota met, to true. And then if SQM, all right, if it's true, we output sales quota met. Let's run it again to see if we do not meet the quota. All right. So say we put in, they sold 1 car for that particular period. All right. We should get the results of what? You have not met your quota for the month. Okay. So that's pretty much how the Boolean value works in the program. All right. But let's go back to the notes and you'll see that we don't have to use true and false. All right. We can use integer flags such as 0, and 1 or anything other than 1. All right. So it tells us that integer flags, the integer variables may also be used as flags. Okay. Now, this is because C++, all right, in C++, the value 0 is considered to be false. All right. And any non-zero value, 1, 5, 100, -1, -5, -100, are all considered to be true. So anything 1 and to infinity and -1 to infinity would be considered to be true. All right. So in the sales commission program previously described, we could define the sales quota met variable. All right. We could define the sales quota met variable with the following statements. All right. Int sales quota met equals 0. So what they're doing is setting sales quota met to be of an integer value. Okay. Now, once you set it in an integer value, now you can say, okay, if sales quota is greater than or equal to, if sale is greater than or equal to the quota amount, you could set sale quota to 1, else set it to 0. All right. So let's look at that in our program. All right. So let's go back to online GDB, and this time we're going to use an integer flag. So what they're saying is, I could change this to int, but if I change this to int, it's going to change it from what? A bool value to an int variable, and now I have to use integer values. 0 is what? False, right? So now I need to change this. I can't change this to 1. True, 1 is true, and 0 is false. So I change it to an int value. Okay, set it to 0, which is false. So if sales quota is greater than or equal, well, if sales is greater than or equal to quota, set SQM to 1, else set it to 0. Then we ask if SQM, if it's true, we're going to do this. If it's false, we do that. So let's run it and see what happens. All right. So now, enter number of sales. All right. So I'll put 5. That's going to make it true, right? So what's going to happen is, if sales quota, if 5 is greater than 3, greater than or equal to 3, it is, then we set an SQM to 1. So it skipped this. So when we go here, if SQM, yes, it's 1, so that's true. It'll do this. So when we hit enter, it should say what? You have met your quota for the month. So let's run it again, and we'll put 1. So they sold only 1 car for that particular period. And look, you have not met your quota for the month. Now, notice here, see how sales quota is 1? All right, I could change that to a negative. Well, a negative 11. All right. So if sales of number of sales or enter number of sales, say we enter something greater than or equal to 3, we're going to assign SQM to be a negative 11. All right. What should output if it's a negative 11 when we ask this question here? If SQM, it should be true. Remember, any non-zero value, when we ask if and whatever that variable is, if it's anything other than 0, that will yield to be true. So let's run it. All right. So we run this. All right. And we'll put a positive, say we put 4 in, and right. If 4 greater than 3, yes. So we're going to set SQM to negative 11. If SQM, that's going to say true. It's going to be a negative 11. It's not 0. Anything other than 0, it will still print this. Right? So let's hit enter. You have met your quota for the month. All right? So see how using integer flags, it still will work. But with integer flags, 0 is false. Anything other than 0 will yield true. Okay? All right. All right. So that ends the flags and the integer flags section.